for coming to the OpenSUSE conference. This is my first time to the OpenSUSE conference. I've tried to come on many occasions in the past, and this is my first time. I'm glad that I have come. My name is Craig Gardner, as you can see on the screen, and you might be able to guess from my email address and for the format of this particular slides that I have, I work for SUSE. I'm even wearing some SUSE clothing here. And I've been working at SUSE for many years, for a little over 4 years, and enjoy working at SUSE very much, and not the least of which the reason that I get to work with the OpenSUSE guys as well. I have been a part of the OPS services team at SUSE for these many years, and as such I have had many opportunities to be involved in this important topic of configuration management, as we have tried to standardize on systems and be able to deploy systems and be able to make sure that we can recover when something goes wrong. So I'd like to share with you some of the experience that I have with configuration management. The title of my presentation suggests that I'm going to be talking about Puppet, but make no mistake, it's not so much that I'm trying to sell you specifically on Puppet. What I'm really trying to sell people on is the principle of configuration management. And my configuration management experience goes way back beyond my working on the OpenSUSE, with the SUSE OPS services team. Back when I was in college, I was a systems administrator at the university, and our configuration management technique was that each critical system had sitting on top of the system a notebook like this one right here. And anytime that you installed software, anytime that you made a configuration change, anytime you did anything to that machine that you intended to have it be reproduced, to have it back to that state again at some later date, you opened up that notebook and you wrote a log entry in that notebook to say, this is what I changed and this is what the system should be. Well, that's not very effective. I mean, it was okay for us back then when we were talking about a small number of systems in our very university setting of 10, maybe 12 different servers. But it doesn't scale at all. The number of systems that you have to manage with a notebook for each one doesn't work at all. Or particularly when you have to do something along the lines of, well, I guess that's really what I should say here about this bullet point about scale is, if you now need to deploy multiple servers to adapt to an increase in load that's coming from users or something along that line, that becomes just impossible to be able to immediately scale up machines or scale down machines based on user demand. And when a server crashes, the notebook works okay, but it's just not the most reproducible mechanism for this. And if you have to spin up a whole bunch of identical servers or services, notebooks fall apart really fast. So it just doesn't work very well. It was great for its time, but people got smart, systems got more complex, and systems got larger. We needed to have some good software to be able to manage these things with some good practices to go along with that software. And that's what leads us to configuration management. And I'll start by talking a little bit about Puppet. And who doesn't love Sockman here? Sock Puppet, what's his name? I can't remember, from Little Big Planet. My kid, Sackboy, that's what it is. Thank you, Frederick. Sackboy. My kids love this game. I used to play it with them and I've already forgotten his name. Well, Puppet has a huge user base, which helps it significantly in terms of people trying to use it for real-world problems. So it has become quite robust, quite a lot of features, and solves a lot of configuration management problems. And so it's a good tool to use. Because it has a huge user base, it also continues to have a growing developer base, which provides some more robustness, some more flexibility, some more sophistication. It's growing very well from a developer perspective. It also has a very specific domain language that people don't have too much trouble learning. Yeah, it's a little quirky, but not too bad. You can use Puppet on a variety of different platforms, and because it's been around for a while, and because it has the wide user base that it has a significant mind share associated with it. A lot of solid, committed, passionate users of Puppet. And really the main reason that you want to use something like Puppet or another configuration management tool is because all of those notebooks just haven't worked. They just don't solve our problems the way that they used to anymore. So then let's spare a moment to talk about Chef. Chef is great in very similar ways and for very similar reasons. Chef is a more recent development. It doesn't have the broad mind share that Puppet has, but it is a growing, popular tool for doing much the same thing. And note that Chef was largely inspired by Puppet. Now when I say that, that's a nice way of saying that the people who invented Chef didn't like Puppet, they wanted something else. So they built something else, something new, something that does the same things just in a different way, and we'll analyze that here in just a minute. And we've got this newfangled thing that I keep saying is just a fad, but it's not. DevOps. More and more, we're narrowing that space, we're narrowing that time between the developer role and the operations role. And tools like Chef help you to economize and make more efficient the means of delivering those solutions directly from your developer base to those who are going to be using it. Does that mean that we cut out testing? No. But that's a discussion for another day. Now, one thing that too often gets overlooked when we talk about configuration management tools is this old dinosaur called CFEngine. By the way, I think immediately following my talk, not in this room, but somewhere in this building, somebody is going to be talking about CFEngine. And if you're interested in configuration management at all, you need to go listen to this, because I'm just going to touch on the surface of this. CFEngine is significant. CFEngine is powerful. And let me tell you what CFEngine provides for you that Puppet and Chef don't provide. CFEngine is the most stable and mature of all of them. It's been around the longest. It is the most, has the most development time devoted to it. Both Chef and Puppet owe a lot to CFEngine because they borrow almost 90% plus, I said almost, 90% plus of the principles and concepts from CFEngine of what to do about managing configurations. The best thing going for it is that it's written in native C. What does that mean? It has a huge advantage over any of the other that have to drag along with it an interpreter. Ruby. Ruby's a huge ball of wax. Ruby is good, Ruby is powerful, but when you're talking about cloud deployments, you want to be able to put out to your cloud infrastructure the smallest, the most essential pieces out to the base that you're then going to instrument and outfit with all the rest of your application. If you want to have speed and efficiency and a small size that becomes much easier to manage, this is the way to go, because the only thing that you need to put out to your cloud systems is the kernel, the toolchain glibc, and the CFEngine agent. And from there, you can do anything to configure that box. It's powerful and it's a good solution, but too often overlooked. Now there are other solutions that are also very interesting, and I think that one of our colleagues is here. I don't know when. I wish I could remember. The Ansible talk? 5, so that's the one that's just immediately followed. Maybe the CFEngine guy was before me.
No, I think it's scheduled for Saturday.
Okay. So at least for sure you have the Ansible one, which is going to be 5 o'clock in the main one. And that's worth going to. Ansible is the newest of the ones that I've already talked about. And one of the key, as a matter of fact, there's the guy's name who's giving the talk on it. One of the most interesting features of Ansible is that it is agentless. Agentless. It uses SSH as its agent. And so it's not even really a client-server kind of application the same way that the others are. You can put the server on any machine in your infrastructure, and any client that listens on SSH can be a target for Ansible. Now it has some weaknesses along with that, but it is very powerful and very useful, and it's very lightweight in the way that you go about configuring systems using Ansible. There's another cool product that's called Salt. As a matter of fact, the reason I bring that up is because that comes from my hometown. I live near Salt Lake City, Utah, in the United States, and that's where this name of Salt comes from. Now it's still quite young, but it was in 2013 Black Duck Software's Gold Medal Award winner for the best up-and-coming software project. And it's really quite good and something that's worth looking into. But the underlying statement that I want to make here is, I don't care which one that you use. Pick one that solves your problems and use it. And here are the characteristics that I think you should consider when you look at the kinds of options that are available to you. You want to make sure that you pick something that you can automate. You want to make sure that you can pick something that has version control to it, because when you're talking about configuration management, you're all about versions. Today your server exists as in state A, and tomorrow it's going to be in state A prime. And sooner or later it's going to be A prime, 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 prime. And there's going to become a day when you want it to not be A prime, 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 prime anymore. You need it to be in state B. And to have version control to manage all of those configurations for your systems is critical. Make sure that you pick a tool that allows you to be reproducible, and of course that has something to do with version control. Also, make sure you pick one of them that ports to all of the different platforms that you're using, and not all of them do. For example, Salt. Salt doesn't port to all of the platforms that CFEngine will. Puppet, Chef, and CFEngine, they pretty much cover everything that you and I are going to be worried about, and a little bit more. Make sure that you pick the solution, pick the configuration management tool that solves your problems, that's actually going to be able to deliver the kinds of services that your operation needs, that delivers your DevOps software, that delivers your Apache configurations, that's able to make your configuration changes to your Apache. Make sure that it solves the problems that your organization needs to solve. And then the last one is, use the one that your team can use. Because if you come in and everybody on the team has no idea how to read Ruby and nobody has to write Ruby, maybe one of the Ruby solutions isn't the right choice for you. Yeah, you could spend time in teaching people Ruby, and there's value to having your team understand Ruby, but that might not be where you want to spend your time and your efforts. Pick the one that's going to make sense to you and your team today and going forward. So, this is not to say that one is better than the other, but let's compare a few interesting features of Puppet and Chef. With Puppet, you have Puppet's basis is Ruby, but it has a very watered down domain-specific language that it enforces upon you, which is useful because it's very specific. You only do what configuration management things you intend to do, and not everything that Ruby intends for you to do. With Chef, you're basically given, for good and bad, the whole power of the Ruby language. Back to Puppet. With the Puppet implementation, you have a CLI on the client that's called Puppet. Similar to that, you have with Chef, you don't have a chef command, but you have a knife command. With Puppet, you're going to collect all of the node data from a third application, a different application called Factor. For unit tests, you're going to use a third application called Beaker. For managing your configurations, you're going to use another kind of technology called Hiera, which is actually built in now. It wasn't in version 2 of Puppet, but now in version 3 it's built into Puppet. With Chef, you're going to have the same kind of node data collection with a tool called Ohi. With unit testing, you use this cool thing called Kitchen. And for your configs, you don't have this third kind of application thing. You just go ahead and use Ruby to manage all your configurations. If you need to go into your kernel config and you want to change this kernel config parameter, you just write a little script in Ruby that goes in, runs on the target, changes that parameter, and returns back that it was successful. An interesting thing about Puppet is that you can basically use any version control configuration management that you want to, which is helpful. Let me point out that you also can use any version control for Chef that you want, but it happens to have Git capabilities built right into it, which is really, really helpful. Now again, that's a double-edged sword yet again, because does your team know how to use Git? Maybe not. So if you have to teach your team how to use Git, that's a learning curve and it might not be the right solution for you. But Git's very powerful, Git's somewhat universal, and Git's built right into Chef. Pros and cons. One thing that people say all the time, which isn't entirely true, but is commonly accepted because people say it all the time, is that Puppet is a more system administrator oriented tool, whereas Chef is more of a developer oriented tool. And that has a lot to do with the fact that Puppet obscures Ruby and Chef takes full advantage of Ruby, and so programmers identify more closely with a real programming language rather than just a very watered down domain specific language. Again, the key to takeaway here is, whether it's Puppet or Chef or one of the several others that we have, you want to kind of identify these kinds of expertises that are within your team and the kinds of problems that you're trying to solve, and pick the right tool for your team, for your organization. One last thing that's important for me to mention, it's kind of a selfish thing for me to mention because it's a SUSE-oriented tool, a SUSE-created tool. It's a SUSE passion right now, and that is the machinery product that we have developed. And sitting in our midst is Thomas Gottlicher, who is one of the principals for that team. This is a very interesting project, and I'll call your attention here to this website. This is the machinery website. Thomas will be giving a presentation. Tell us when. And which room? In the main room. Tomorrow, 3 p.m. in the main room, where Thomas will give us all of the dirty details. So I'm not going to give anything away. But this is compelling. This is something that's worth looking into. Now, it's not the same configuration management kind of tool that we're talking about in terms of Chef and Puppet and CFEngine. But it's a very specific tool that Thomas and his team and many of the customers that we deal with have said to us, you know, there are some things that we just don't like about those other products, and that they don't do what it is that we need them to do. So it fills the gaps that current tools don't address. We have some steps further down the road that we need to go with it, but I think you'll like it. And it's worth going and watching his presentation to see what you can do with it. It's also interesting to note that I can't make any announcements, but other things that we plan to do down the road with machinery that will be very interesting to watch happen over the next couple of months. And there's their cool logo. I like this. Anything you want to add, Thomas?
It's not only SUSE specific, so we also target other operating systems. So listen to the presentation tomorrow, you get some more details on that.
Great, yeah. So to repeat what he said, make sure you understand that it's not, even though we invented it and it's solving problems that we think are important, it's not a SUSE-specific tool. We incorporate the ability to manage a variety of different platforms and systems with it. Thanks. All right, now I originally wanted to have at least only a brief demo, but the amount of time that was afforded me for this presentation, including a variety of other technical calamities that took place last little while, it just wasn't going to work out for me to show you a little bit about Puppet. But it's fairly simple. Let me, before I get there, just share a few things about Puppet. It's client server, so is Chef, so is CFEngine. It's written in Ruby, well, so is Chef, but not CFEngine. It's secured through SSL certificate transactions. Now, Chef uses not SSL, but uses GPG, PGP, and there are other security mechanisms. You'll want to make sure that you want to use a tool where the kinds of things that you're telling your managed systems to do and how to behave and what to be, that's a secure transaction. You manage all of the different recipes, what a server is and how it's supposed to behave, what characteristics it's supposed to have. And you have a variety of things to do that, to manage those systems through, as I mentioned on a previous slide, a tool called Hera, which allows you to manage the hierarchical structure of a variety of configuration settings. Factor, which tells you a bunch of things that I'll show you some examples here in a moment. The facts about the system. And Aegeus, that also allows you to do other configuration file kinds of changes. And it's an entirely declarative language, a domain-specific declarative language that says, be like this. I don't care how you get to be like that, but this is what I declare you to be. Web server with this characteristics. How that all happens is all black magic, black box stuff happening behind the black curtain. Just like Chef, Puppet server has a server side. It's called puppetmaster on the server side, where you maintain all of your modules, which is you want to manage SSH, how SSH is supposed to behave. You would create a module that defines how SSH is supposed to behave. You have manifest that represents all of these different servers. I have server A, I have server B, I have server X, I have server Y. All of the different managed systems are what make up the manifest. And then all of the different recipes, how to use those modules, how to manipulate those modules to have a system that's in your manifest behave a certain way or not behave a certain way. That keeps on the server side a database of all of the puppets. Those managed systems are called puppets. All similar but not identical nomenclature all throughout all of these different technologies. The Puppet server runs as a daemon, and it doesn't run as root. It runs as its own unprivileged user called Puppet. You can run it as root. I would not recommend that. And then the server configuration is managed on the server side with this file called puppet.conf. And typically, although not exclusively, you would have a server in your domain that answers by way of DNS to the name of Puppet. That's the standard, that's the default value. You can configure it differently. But if you just use that default, it'll just go out and ask the client, when it looks for a Puppet server, is going to ask for a host by the name of Puppet. And then on the client side, you have similar kinds of things. I'm using Puppet as the example. All of the others do similar things. You have a client that could run as a daemon, as an agent. You can just cron it up to run periodically, however often you want it to run. If you run it as a daemon, it's just going to answer anytime the Puppet server calls to it. If you run it as cron, then anytime cron iterates, it's going to ask the server, do I have any configuration updates? And it's going to give them to you. Or you can just run it manually. And when you run it for the first time, you have to do an SSL certificate authentication. Same thing with GPG. When you're talking about Chef, you have to make sure that these transactions are authorized. And as far as Puppet is concerned, you've got that puppet.conf file that's in the actual same place as the server file, so you can technically have the client and server running on the same box, although that's not necessarily a wise thing to do. And then a few interesting things about Puppet 3, which is recent, not that recent now, it's almost 2 years now. Yeah, so maybe I get rid of this slide now. But it's a lot faster. We refactored and threw out XML RPC, and it's entirely REST now. Hyra, as I mentioned, is an integral part of Puppet. And the most recent 2.x stuff will certainly work with 3.x stuff, but you get any all older than that, you might have some problems. So it's best if you're updating that you upgrade 2.4 or 2.5 to 2.7 before you move on to 3.x. Just standard client server stuff that you'd expect to see. You have the puppetmaster here with all the different puppets that it communicates with bidirectionally. Back on the puppetmaster server side, you keep this variety of manifests and modules, and then you keep a nice database of all of the different configuration data that comes from the puppets. All of these platforms and more, these are all the ones you care about, right? Puppet and Chef and CFEngine all are going to cover this span here. And Ansible. Typical things that you want to control, configuration management wise, users and user authentication, what packages are installed, and more importantly, what packages are not installed, right? That's just as important, if not more so. Making sure that certain services are stopped or started and the kinds of dependencies that may be involved there. Asserting specific configuration settings. Deploying configuration files, not just changing them. And any other files that you want to deploy to each of the systems that you're managing. And one of the most significant use cases for the development of Puppet was the marriage that it had with Nagios. One of the huge user bases for Puppet are those who use Nagios for monitoring, and being able to push out all of those Nagios rules to the clients is very easy to do with Puppet. Can you do it with Chef and others? Yes. It's simply that Nagios was the driving force behind some of those key features of the development in Puppet. And you can think of terms of all of these programming characteristics like types and classes. You can go through a lot of sophisticated inheritance, whether that's good and bad, because sometimes coupling is not a good thing to go through. Variables, arrays, conditionals. If I've got Red Hat, I want my web server to be referenced as HTTPD. If I've got SUSE, I want my web server to be referenced as Apache 2. Conditionals that allow us to do those kinds of things fairly easily. You can also put together your own functions and defines to make it more sophisticated. You manage a variety of nodes and characteristics based on those nodes. And although Ruby is not directly exposed in the same way that Chef is, Puppet still allows you to use Ruby characteristics through what we call templates. Here are a bunch of the standard native types that we talk about. Make sure that package is installed. Deliver this file. Make sure the host is called this, or behave a certain way when host is called that. Distributing SSH keys. All of these different kinds of native types that make it easy for you to manage each of the puppets that you are managing. Similar things that exist in Chef and CFEngine. A Puppet example here, if I were to be managing Apache manually, I'd SSH into the server, and I would run zipper install Apache 2. Then I would edit this configuration file and a bunch of other configuration files, and then I would start it up and make sure that it works. The Puppet way to do exactly the same sort of thing is I don't SSH into the box. I write this Puppet module that says, make sure that package Apache 2 is installed. Deliver to the Puppet target, the agent, the file that's going to land in this space. And where is that file going to come from? It's going to come from the server side, this file that I have located on the server side. And then once that stuff is done, make sure that Apache is started. Simple. Declarative. Very easy to do. Puppet, Chef, you would do very similar things. CFEngine, although the language of CFEngine is a little quirky and people don't like it and it's antiquated, you do the same thing. You have that tool called Factor where you can harvest all of the information about all of the different puppets that you're managing. Here are some examples of the things that you see from the puppets. what the kernel version is, a variable that you can use. All of these are variables that you can reference. And things like which operating system it is. You can even tell whether the system that's running is virtual or physical. A chef example, similar to the one that we had from the puppet example. In this case, we even have this way of having conditionals to behave a certain way when we're Ubuntu or Debian, or when we're SUSE, and then at the end make sure that we start the thing up and it runs. Here would be the demonstration, which I am going to, I hope, tactfully decline to do. But you can see the power that you have. And you see you have the ability to scale things. You could have this whole infrastructure of web servers, this whole infrastructure of DNS, this whole infrastructure of file services, and keeping them all managed from a centralized server using configuration management to know when things change, that it's a change that I intended to change. And anything that anybody does that's unintended will get restored appropriately. And when a system crashes, I don't have to panic and race down and go ahead and to tear that machine out and try and get a replacement, try to remember what all the settings were, try to remember what all the software was that was installed on that. I stand up a new server, whether it's a physical machine or some cloud machine, and I deploy that configuration to that web server to bring it back up after a crash. Or if I need to spin up 9 machines to handle the huge load that's coming, I have a mechanism to do that predictably, reproducibly, effectively, and efficiently. So, configuration management, do it. And I'm happy to answer any questions that you may have so that you can keep stuff automated, you can keep all of your systems regulated and auditable, and then it's much easier to do than a spiral-bound notebook. My name is Craig Gardner. I'll put my address back here up at the front. I'm happy to answer questions here, or if you want to write me email later, I'm happy to. Any questions? Cornelius.
I have one question. So you have how much whatever, it's very efficient to manage things, but you can also efficiently break your whole data center if you keep doing wrong. So what are the best strategies from your experience when you're looking to test the cookbooks, manifest, whatever?
That's a great question. And I'm going to answer your question by saying, nothing ever breaks for us. We are perfect. We do it right every time. But, but you know that's not true. Yes. Yeah, that's always a tough one. This textbook approach to that sort of thing is similar to any other production environment that you would be in, is that you want to have a test environment where you test these things out first before you promote them to production. And that's true of a variety of different things that we do in the software environment, including DevOps, right? We need to test the application that we're deploying, and we need to test the means to deploy the application that we're deploying. And when things go wrong, that's another good reason to have good monitoring systems like Nagios that are going to report to you the kinds of things that might be going wrong as quickly as possible. Other than that, you've just got to have a skilled team that trusts each other and that you back each other up. You know what to expect from who's involved in that team, and know that it's software, right? Things are going to go wrong, and be able to react to them efficiently. If you've got good process, if you've got good discipline, and you've got good skilled engineers with the right tools, they can do the right things. Even when things go wrong, they can react quickly and make things right. Not the answer you wanted. Thanks, Cornelius. Daniel.
So, I mainly use Gentoo and Arch Linux, so I know that my package managers will figure out if I have changed the configuration of a certain package, and they will not just override it. So I can feel free to take a look at a new file or whatever and compare it to my file and see if I need to make some changes so it will run with the newer version of the package. save them so I can redeploy them easily.
I will try to summarize what it is that you said, which is an interesting problem that I think Ansible is the kind of thing that handles better than these other ones do. The question is, I don't want to be, I'm summarizing and I'm sorry to say that, I don't want to be beholden to all of the bulk challenges that come from an entire package. I want to be able to manage just the changes that happen for a specific change that came in a specific version of an RPM package or other package, whatever it may be, and deploy only that change. And this is a feature that, well, certainly you could get around that by certainly not using a package manager at all, right? Just put in the right files in the right place on the server that then can be deployed. But that's not a good solution, is it? That's not a good solution at all. There isn't really a good way of doing that yet, but that's a good use case that I think would be interesting to propose to the various communities of these projects to see how you could better economize and be more atomic in the kinds of changes that you want to push out in the context of existing technologies like the package manager. Thanks, Daniel. Other questions? Yes, please.
One of your last sheets, there was even a rescheduled. Why is the rescheduling important for you?
I'm sorry, I didn't quite understand.
We did the very last sheets.
Stop. Good, okay. Question is, what would be important consideration to run the client as a daemon versus running it as a cron job?
More specifically, as a system administrator, I have installed and configured my machines, and I'm happy with my job. My configuring and installation is done. I'm focusing on sheets. Then I do illustration, but I prefer to use Ansible. When I'm working on that machines, I don't want to have automation tools, updating, or whatever. That's in fact my real question. Because I don't understand the need for having a daemon that is tweaking, modifying my machines that I already did. Because I'm busy with all machines.
So if I'm going to be able to summarize correctly, you're saying that in your workflow, you may want to go out to system A and make a manual change to it. And before you get around to creating a recipe for that for Puppet, I'm sorry, I'm mixing metaphors there, right? And create a rule for that, create a module or a manifest datum for that. You think that the daemon running on system A is going to overwrite the changes that you have made manually on system A, and you don't want that to happen.
Indeed. I'm all thinking of when I have configured the datacenter A already, and I'm working on datacenter B with the same orchestration information.
Uh-huh.
I don't want to have updates in datacenter B
but perhaps that you could it depends on your workflow, right? A variety of choices that you make here. You can divide up your different manifests into a variety of different classes, right? You could say that this manifest this definition of machines applies similarly. It's the same sort of functionality that I have for data center B as I have for A, but I want to treat them differently for whatever reason that you may have. And so you would create a manifest for these servers in data center A, which would be different manifest of machines that you have for data center B. And then you would apply the changes for A that would not affect B until the time comes that you implement those changes for B, and they could then be independent. They could still be demonized, but because you've divided them into two different classes of systems, they can be managed independent one of the other with the same rules.
Okay. Now you told me a different process. Now back to my original question. What is the benefit of having all jobs having demons?
Good. So again, it depends on your workflow. Perhaps you are in a circumstance where you don't want to have traffic happening on your wire because it's expensive at certain times of the day. And so if you had it demonized, it would try to make all those changes all at exactly that time of whenever the change gets made on the server, all of the client side things would start cascading immediately. And you don't want that to happen at a particular time of the day, or maybe not because it's expensive, but because it's during a production time, right? It's during a time when there's not supposed to be any changes to the systems. So you might say we only run the client-side updates between midnight and 4 a.m. and cron them up appropriately. Does that make sense?
Yeah, that makes sense.
Okay.
Thank you.
Yes?
Another advantage of having D, you sometimes have application administrators that think they're smart and make changes, but slaps them and stores your config.